All right, so we'll wrap this up with this problem here, just looking at it. Now, I did 49 and 52. 49 and 52 we'll take a look at in class also, real quick. And that'll be good. 52 is kind of fun. I mean, it's finding the center of mass of something. So let me just show it to you real quick. Okay, so the center of mass of this thing, if you knew nothing about finding the center, do you think you could balance it? It looks like the center of mass might be right here, because this is perfectly balanced. But in fact, the x center mass should be at 0. I mean, if you didn't know any better, wouldn't you just say, yeah, you could balance this sulfur and oxygen, and just knowing that sulfur is twice as massive, so this is 2m, and this is m, and this is m. And here's what we got to do. We got to do the 30 degrees off here for the x-axis, the 30 degrees off here. So we'd find this is 1.43 nanometers, and you can just leave it in nanometers. So it'd be 1.3. I'm going to see what they want the units to be in. Yeah, nanometers. So that's nice. So they let us do nanometers. So you don't need to convert this times 10 to the negative 9 or anything. Piece of cake. We'll take 3 or 4 minutes in class to do this. I just don't want to download it here on a Friday afternoon. All right. Anyway, so we're going to move on. Now, here again, now on problem 49, you're going to find the center of mass of two, the velocity of their center of mass, which is just the momentum before divided by the momentum after, and then you find that velocity for the momentum after, and that's the velocity of the center of mass. Stop talking with your hands, all right, especially when you can't see me. In other words, on problem 49, you've got two railroad cars. Okay, one has velocity, this is car 1, and it has velocity, initial velocity 1, and this is car 2, and it's going a little bit slower. I should make this one a bigger velocity, but this one's going a little bit slower. Like say this one's going 1.2 meters per second. Let's say this one's going 0.8 meters per second. Eventually, they hook up, all right? Eventually, they hook together. But to find their center of mass, the velocity of their center of mass is not that hard. It's not that hard. You just take their momentum of 1 plus the momentum of 2 and divide it by mass 1 plus mass 2. That's it. Now, when they hook together, their momentum before is going to equal the momentum after. So I wonder what the velocity of the center of mass is. Look what you're going to wind up with. The momentum before is the momentum of 1 initial plus the momentum of 2 initial is equal to, now if they're hooked together at the end, what's this going to be? All right, they're hooked together, so you got mass 1 plus mass 2 times the final velocity. You figure that out. Take that, find that velocity. I bet you it's going to be the same thing as this velocity. I didn't mean to do that, but I did. All right, so we'll go ahead and we will go on to problem 62 now.